Hi, everyone. My name is Jenny, and I'm here with my colleague Sheldon Hendricks, and we're excited to present our submission for the GraphRAG and ArangoDB hackathon. Our project is a next-gen agentic app designed to extract deep insights from GitHub repositories or GitHub repos. The goal is to help developers, researchers, and software teams better understand and optimize large code bases using AI, GraphRAG, and ArangoDB. So the problem. Software projects are growing in size and complexity. Developers often struggle with one, navigating large repos with thousands of files, two, understanding the relationships between functions, classes, and modules, three, tracking how dependencies evolve over time, and lastly, identifying key contributors and how code is structured. Recently, I was trying to contribute to an open source project, and I was amazed with how many commits. There were thousands of commits and hundreds of files. And I have spent more time trying to find a place to start. And I felt, oh, it'd be nice if I could ask somebody that was familiar with the project or the code or the files to be able to help me pinpoint where to start or how to tackle the problem to contribute to that project. But currently, existing tools provide only surface level insights, but they don't reason over the code. This is where our solution comes in. So why GraphRAG? So traditional RAG models rely on vector search, which can lead to hallucinations and fragmented results. GraphRAG improves retrieval by preserving contextual relationships between code entities, minimizing hallucinations and improving accuracy, allowing structured, explainable AI-generated responses. By integrating GraphRAG with ArangoDB, we ensure accurate, graph-aware AI reasoning over GitHub repos. Now, let's dive into the technical details. Our solution consists of four key components. One, data ingestion. We use tree sitter to parse GitHub repos and extract code structure such as classes, functions, and dependencies. Commits, contributors, and file relationships are also captured. Two, graph storage with ArangoDB and NetworkX. We structure the parsed data into knowledge graph stored in ArangoDB. Each node represents a code entity and edges define relationships, such as function calls, imports, file ownership. Three, AI-powered querying. Using LangChain, the system processes natural language queries like, what function is used most across this project? What are the most important files in this repo? How have dependencies changed over time? And four, visualizations and insights. We leverage 3D graph visualizations to make complex relationships intuitive for developers. Now I'm going to pass this on to my colleague, Sheldon, and he's going to give you a live demo of our project.
Yeah. So as we can see over here, we have a Jupyter notebook, and we have basically extended the base template that was given to us. So basic dependencies that we have installed, we are running this on a T4 GPU, and yeah. So as my colleague said, basically we are trying to store all our data in the ArangoDB. And the first step that we used was to pass our data. So since we are trying to clone a database repo, what we are doing is basically we have a parser that we have written that basically extracts the function, the classes. It's a relationship. So it's basically a directed graph where, say, function A calls function B, or file A contains functions A, B, C, or class A contains methods A, B, C. So based on that and some information is what we are actually storing in the graph. So this is basically how we are creating our graph. For right now, we are only focusing on Python files. So that is basically what it has extracted. And here we are basically calling the build graph function that uh, goes through all the files in this particular repo. This is a smaller size repo, but this is just for demo purposes. That's why we have chosen a smaller size repo. But yeah, it goes through all the files and then it creates this directed graph with 93 nodes and 168 edges. Although it's a really small file with basically 7 files. So we have our nodes where we have files as nodes, different functions as nodes, and classes, dependencies, all that kind of thing is basically captured in our graph. We wish to capture more data as we move forward, like commits, so that we can see how, say, a particular file changes over time, or a function, how it changes over time, so that we could interact with that data. This is the predefined function to visualize graph, but we didn't like it enough, so we wrote our own visualization function. So right now we can basically visualize the graph. We can see, okay, the main file has basically, it calls particular functions. It's a 3D graph, so we can like move around and see like the variables that it has, and the methods that a class has. So once that is done, we are basically loading our data into the graph, into our ArangoDB. And yeah, if the data already exists, we can directly just reconnect it using this function. And yeah, so here I can see if I try to access node 45, I can see it has a degree of 1. Some simple queries that we have written in AQL, they basically give us these results where we get the nodes, or basically if we want to just see, oh, node 1 has what all edges. So here we can see node 1 has these all edges. So basically it is a file. It has inheritance, number of methods, modification time, its size, a lot of metadata about the file and the functions that we are storing. Again, we can visualize this. I think this is a better visualization because now we can see like there are groups where some files are not being called. But yeah, if we go into a particular section, then we can basically see how this method calls these variables. And yeah, there's more metadata about these variables, but they're not visualized in the graph. Maybe that could be a future scope. Anyways, moving on, we can experiment with different keynotes. And here, basically, we are using DeepSeek API to basically call and query the functions. So some basic functions, that tools that we have created is text to AQL tool. This tool was provided already by the team, so we just modified it a little more according to our needs. Similarly, the text to NQ or NX algorithm to text, this function as well, we have modified so that we could improve and provided more data about our files and our data. We basically initialize ILLM, and we try some basic questions. So what's your favorite fruit? Since the tool asked you to say avocado, it said avocado. Now, which file has the most methods? So basically, I can see over here the game file, or the repo/game file. This is one of the main files that contains most of the methods. This is the main class. So yeah, that class is there. Uh, Actually, I had some errors with that one. But yeah, going forward, we can see like the node 1 is the game class, and we can see what all methods does it have. And yeah, it gives us a summary as well. So the same thing can be accessed through our, so let's say, uh, find a node with the game, and can use a UI as well to query. Uh, Query the results, find the name. Uh, so find the node with the name game, and basically we can find the node. Then which all function methods have been connected to node 1 basically gives us a summary that this is a file and what all has been connected, what design patterns have been used in this repo. We could ask it that and basically get more understanding without a third person. If it was an open source project and I don't know what is happening over here, I can basically query and ask it. Uh, yeah, and basically this is our UI that we have been calling. So yeah, for future enhancements, I think we can basically add the commit history as well. That is one important feature I think that will set us up, set us apart from competitors like Ada, that basically just queries the main graph, like the main branch, and gives us only context of what is currently on the main branch, but then doesn't know any history of this graph. It will be a multi-layered graph with each layer having a particular time-based query. So yeah, we could ask it, oh, on this particular day, what does this file look like, and how did it change, or how did a file change over time, or why did somebody go ahead and change this, or who changed it. So I think a lot of data could actually be just found out using this. So yeah, as you can see, we found the name and it's located over here. And we could ask it more questions as well about the functions that it has, or say suppose we want to change a function. Say we want to change the draw function. We could go ahead and ask it which all files would be affected if I which file would be affected if I change the draw method in game class. Uh, this Yeah, so some of the problems that we faced was passing the tree. So firstly, we are trying to pass the commits, and it was not as good as we expected because the graph was really confusing and difficult to interpret. But yeah, I think as we keep modifying this, we could improve this particular graph so that a developer can visualize it much better and see over time how the something is changing. Another thing that we had an issue with was the naming convention, I think. The nodes had weird names like Node 45. So that was a little difficult to query. Although we understood that using AQL, we could query it better, say name.type, and then find things like that. So yeah, I think those are some future enhancements. I think later on the AI can basically query and suppose we ask it, oh, change this particular function. It could go ahead, it could try to find whatever nodes it needs, get the data, get its relative data, and basically change those nodes. So I think that would be really good. So yeah, Jenny, do you want to conclude? Uh, yeah. So to conclude things, basically, I think this project shows how our GraphQL and ArangoDB can basically transform how we analyze the GitHub repos with structured graph retrieval, obviously, and with AI-powered reasoning and deep insights. So basically, it's like a senior developer who is always with you and helping you. So yeah, thank you for watching, and I'm excited for this project. So looking forward um, for any feedback that would be provided. So yeah, thank you. Mm, Stop sharing.